Welcome back, guys. So for this video I'm going to explain a bit more about how to convert between decimal and binary, but first I need to show you what the most significant bit and the least significant bit is. And very simply, the most significant bit is the leftmost bit of your binary number, and the least significant bit is the rightmost bit of your binary number. So with this in mind, I'm going to show you a bit of a brute force method for converting decimal to binary. So I think it's best to just show you by doing an example. So say I want to convert the number 31 to binary. And just so you know, this little subscript down here tells us what base we are working in. So a quick side note, I suppose, say you have the number 10 in decimal and the number 10 in binary. They're not equal, but just looking at it this way, it would be kind of confusing. It's a bit ambiguous. So we put the little subscripts down there just so we know what number system we are working in. So to convert 31 to binary, the method goes like this. You take your number and you divide it by 2. 2 goes into 31 15 times, and there is a remainder of 1. Then you take 15, divide it by 2. 2 goes into 15 7 times, and there is a remainder of 1. 7 divided by 2. 2 goes into 7 3 times. There's a remainder of 1. 3 divided by 2. 2 goes into 3 one time. There is a remainder of 1. 1 divided by 2 equals 0, and there is a remainder of 1. When the quotient is 0, that is when you can stop. So what do we do with these numbers where the remainder is? Well, actually, this is the least significant bit, and this is the most significant bit. So you work from the bottom up. So 31 in the base 10 system is equal to 1 1 1 1 1, where this is our most significant bit and this is our least significant bit. It looks like a 9. So that was pretty quick. So I'm going to do a couple more examples. How about something real simple, such as 11 in base 10. So we want to convert that to binary. We do 11 divided by 2 equals 5 with a remainder of 1. 5 divided by 2. 2 with a remainder of 1. 2 divided by 2 equals 1 with a remainder of 0. And 1 divided by 2 is 0 with a remainder of 1. The final quotient is 0, so we may stop. This is our least significant bit, and this is our most significant bit. So 11 in base 10 is equal to 1 0 1 1 in the binary system. So you might have seen me in that last video convert that number to decimal. And I like doing it while I'm doing these sorts of problems just to double check and make sure, especially when you're starting out learning about the binary number system, because it's really awkward at first. It's kind of uncomfortable to wrap your head around it. So it's helpful to just double check yourself. So converting 1 0 1 1 to 11, you do 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. which is 8 plus 0 plus 2 plus 1, which is 11. So how about one final example? Let's do something a little bit larger. How about 107? So we want to convert 107 from the base 10 system to binary. So 107 divided by 2 is 53 with a remainder of 1. 53 divided by 2 equals 26 with a remainder of 1. 26 divided by 2 is 13 with a remainder of 0. 13 divided by 2 is 6 with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 equals 1 with a remainder of 1. 1 divided by 2 equals 0 with a remainder of 1. The quotient is 0, so we may stop. This is our least significant bit. This is our most significant bit. So 107 in base 10 is equal to 11010111 in binary. Now we want to double check this just to make sure. So with the positional notation, it's going to be 1 plus 2 plus 0 times 4, which is 0, plus 8 plus 32 plus 64. And I like working from the right back. I'm comfortable with it because this bit here is always going to start off with 2 to the 0. If you have a really large number, it's kind of hard to look at this one and just know automatically which 2's to the power in place it's going to be. So we have 64 plus 32 is 96 plus 11 is in fact 107. So that is it for this video. The cool thing about learning how to convert between binary and decimal is that you can just pick any random number and figure it out and double check yourself. There's a lot of quick calculators that you can even use, but you don't really need to because it's quite simple stuff, honestly. But yeah, just getting comfortable with doing that process of dividing by 2. The more you do it, the quicker it'll be, and you'll start memorizing some of the binary numbers. But yeah, check out the description. I'll link some cool stuff down there too, and I'll see you in the next video.